Hi there. My name is Tim Hegarty. I'll be your instructor to the C programming course from VTC. Welcome. We're going to be taking a look at the C language and how to use the C language on Windows, the Windows platform, and on Linux. We will be using the Kernighan and Ritchie, or Kernighan, I should say, the G is silent, Kernighan and Ritchie C programming language book that you see down there in the right corner of the screen. I gave you the ISBN number so that you can look up the book easily at your favorite online bookseller or go to a real brick and mortar bookstore, take a look around and find Kernighan and Ritchie, more commonly known as K&R. We will use it as our guide. K&R is, though, a C programming reference. There are small tutorial sections in it that we'll take a look at, but it does not really tend to want to teach you C. That's what I'm here for. I'll be teaching you C, and we'll use K&R, which is the only book that you will ever need about C programming to really program in the C language. Like I said, we will be doing C on Windows and some on Linux. This is not a C++ or a C# course, just so you know that up front. You will be able to use what you learn in C and about programming in this course if you decide to go on and learn more about the object-oriented architecture of C++ or onto C# and its particular environment. We will install a C compiler on a Windows platform and a Linux platform. We will be using Microsoft's Visual C++ 2005 Express Edition, and even though it's created for C++, it will compile our C code and our samples just fine. Same thing with the GNU, GNU's Not Unix, C++ compiler. We'll make sure that you have it installed properly and updated with the right libraries so you can use it on your Linux system. We will be looking at the process of programming, what has to happen if you're going to become any kind of programmer, and how to work with the C compiler, how to compile your thoughts into a language, and then actually into an executable program. We will look at C data types, operators, expressions, and the expressions are just our data types mixed with operators that give us results. We'll see how to control the flow of a program, how to make it branch in different directions based on things happening or not happening. We'll see how to use functions for some structure in our program so we don't just have what's called a top-down design where it just starts at the top and keeps going. We will use functions to call back and forth and return information and send information. We will use pointers and arrays of pointers and arrays of arrays. It sounds a little confusing, but I think when we build a nice foundation and build from the bottom up, that you'll have a very good understanding of pointers and arrays by the time we're done with that section. We will be looking at how to use structures. Structures are very powerful, and it's how we commonly think of information. A structure like an entry on a mailing list has a name and an address and city, state, and zip, and all of those are different sizes and types of information, and we'll put those together into a single structure. We'll look at input and output. Doesn't do a lot of good for your program to just sit there and not talk to the outside world. So we'll show how to get information into the program and how to get it back out again. We'll take a look at using C on the World Wide Web with the Common Gateway Interface, or CGI. You'll be able to create a form and load it up on your web server and then view it in your browser, put information into the form, and get that information into your program, your C program, and then get a result, a reply from your C program back out to the internet and back out to your web browser. And we will take a look at common files on the server or on the computer that you've written your C program so that you can open a file, you'll be able to read files, write files, and what we call seek to any place within the file that you want to. Now, C itself is pretty small. There's not a lot of reserved words, and it's kind of like the alphabet. There's a lot of small pieces to C, but they can be combined in some very interesting ways in words and entire books. And that's what we're going to do, is look at the standard library of functions that have already been created for us so that we don't have to reinvent the wheel to do just some standard operations. So let's get started. Keep on clicking into our next video, and we will go and make sure that we can actually load and compile a program in our own C compiler. Okay, let's take a little tour in the Wayback Machine and do a short history of the C programming language. C was originally created in the early 70s, along about 1972, by Dennis Ritchie on the Digital Equipment Corp PDP-11 system. Ritchie wrote most of Unix and the C compiler itself in C, which is kind of interesting. Which came first, the compiler or the language? Well, what came first was a handwritten assembler that Ritchie wrote, which allowed him to create the beginnings of the C compiler so that he could write the rest of the C compiler and the other tools like copy and CP and a lot of the other commands that we know in Unix and Linux. Most of Unix and Linux are actually written in the C language. C evolved from languages called BCPL and B, which were from the late 60s and early 70s, and they were both typeless languages. Now, C has its own data types like integers and characters and various floating point precision variable types. So we'll see how to use those later. But C is a somewhat typed language. The C language is known as a low-level language because it fits more closely with the actual machine itself and the machine's language. But C is not so tightly coupled to the machine that it's not portable. C is very portable. The C compilers are available from everything from a palm-top device to a mainframe. So even though it's a low-level language, it is very available. C is able to perform high-level functions by the addition of libraries. The libraries have been created over time to allow us to do standard input and output. There is a whole standard library defined by the ANSI standard, which says to have a real C compiler available, you must also provide these standard libraries, because C by itself is not particularly useful or not particularly programmable until you get some of these libraries involved. More and more government work being done in C required that there had to be a C standard to get the government contracts. So ANSI created a committee in 1983 that its whole goal was to standardize the C language. Well, they worked on that for quite a while, and the result was finally achieved in 1988, and that resulting ANSI C standard is known as C88. The international community, ISO or OSI, however you want to look at that and what language you want to look at that in, they ratified the ANSI standard, and that became C90. There is little, if almost no change between C88 and C90. That is what we will be working with here in all of our declarations and function declarations and type casts and everything else is out of the ANSI C standard or C90. So let's move on and see if we can actually get a compiler working on Windows, get it tested, and get a compiler working on Linux if we so choose. So that's where we're headed next. Okay, our next section is C on Windows. We're going to take a look at how to get a C compiler downloaded and installed in the Windows environment. There are several C compilers available for the Windows environment, and you can find those, probably over a dozen of them, by doing a search for Win32 C compiler on your favorite search engine. The one that we're going to use through this course is the Microsoft Visual C++ 2005 Express Edition. The Express Edition is somewhat limited in what it can do. It doesn't create native Win32 programs and without some other additional software. But we don't need all of that. We're only going to use the command line compiler of Visual C++. Now there are a number of great IDEs or integrated development environments available to you, but they really just get in the way. Let me show you what Visual C++'s IDE looks like. There you go. There's a lot going on that little page, and it's all kinds of things that would kind of get in our way in learning C programming. If we look over here at form1.h, there's our actual hello world text buried down inside of there that I put into this tool, into this label on the hello world page. Now that will of course work well and it will function, but we would learn more about how to use the IDE and how to use the Express Edition than we would really learn about C and C programming, which is why we're here. Like I said, there's many good IDEs available. They all look very similar to that, but they're just going to get in our way. Now, here's where you want to go to install C on Windows XP or later. msdn.microsoft.com/vstudio/express/Visual C. There's a lot of advertising material out there. This is a free product, but Microsoft wants to show you all the wonderful things that it has to offer. So follow the links through the tour, step by step, looking at what Visual C Express Edition can do for you. And finally, at the end of the little tour, page by page, you will find a download link. Obviously, click the link, download the product, run the setup files. You probably have a good background of downloading and running installation programs and things like that. And you can trust that they are probably pretty safe, somewhat inherently safe from Microsoft, though there's probably a lot of dispute about that. But download it, install it. You may have to register with a Hotmail account, something like that. I don't remember that registration being required. But bottom line, the compiler and the IDE are free and will go a long ways towards helping you learn the C programming language. And then if you want to, you can go on and learn the IDE and all of the .NET kinds of things that you can do with the Express Edition. It is incredibly powerful, and especially compared with the free cost. So take a few minutes now and go ahead out to that URL and download the product and go ahead and install it all. And then when we get back to here, we'll take a look at how to test the Express Edition and make sure that it's running. It won't take very long. Now we're going to test our Microsoft Visual C++ 2005 Express Edition compiler, which is actually easier done than it's said. Here's all we need to do. After you install the Express Edition compiler, you click on Start, of course, All Programs, and then the Visual C++ Express Edition item. Now don't go right to the compiler. That brings up the IDE. We want to click on the Visual Studio Tools, then the command prompt. Then we will type CL to run the compiler, and we'll confirm that it actually ran. Let's go over and do that. Here you see that we have clicked on Start and All Programs, and now we have to scroll down to Visual C++ 2005 Express Edition, over to Visual Studio Tools, and then we select the Visual Studio 2005 command prompt. That will bring up a normal command window, and you can see that we are in the program files, Microsoft Visual Studio 8 VC. Now this command prompt has also had a number of environment variables set so that the compiler will function properly. If you go straight into a normal black command prompt and try to run the compiler, it most likely will not function properly. And what's worse, it may appear to function properly, but then not link properly and give you a lot of trouble. So only start the command line the way that I just showed you to start it. Otherwise, you'll have lots of additional problems on top of programming in the language. Now to test the compiler, it's simply CL, enter, and we see that the Microsoft 32-bit C and C++ optimizing compiler for 80x86 is actually running. And it also gives us a usage line that we would type in CL and any kind of options that we might want to compile, which we won't really be working with that, the file name that we're going to compile, and then any kind of link options after the /link identifier. So pretty simple, and we have a working C compiler. Just, of course, type exit to get out of this, and that's what we needed to do. Next, we're going to go on and take a look at putting a C compiler on a Linux system, which is about the same process, but we'll take a look at that next. We want to talk a little bit now about putting C onto a Linux installation. If you've been through a Linux installation, you probably already have a good C compiler, GCC, installed. If you have not gone through a full installation, rebuilding your own kernel, that sort of thing, and you're just looking to learn C, then let's take a look around at what I have installed is Ubuntu, UBUNTU. It's another distribution or distro of Linux. So we'll switch over to that, and I'll show you what you can do inside Linux to confirm or at least upgrade the C compiler that you have there. Let's switch over to my workstation, and this is my desktop inside Linux, inside Windows. What we do is click on System, Administration, and then come down here to what's called the Synaptic Package Manager. Now your particular Linux will have, need a password there, will have a package manager that comes with your distribution. So Red Hat would look different than SUSE or Ubuntu that we're looking at here. All we have to do in the package manager is search, and we'll search for the GNU C compiler, GCC. We'll click search, and it should just take a second to search through the libraries. And there's the CPP. That's the C++ compiler right there. Now, all we have to do is look at the installed version and the latest version. And they match, so we're up to date. We have everything that we need to do C++, or in our case, just simple C programming. So I don't even have to checkmark this or do anything with it. If I did checkmark this and click apply, I could install or upgrade the GNU C compiler or the C++ compiler and get a fresh version. Could close the package manager, and that's all there is to it. If you want to read more about the C compiler, the GNU CPP, simply go to gcc.gnu.org. All kinds of documentation on installation of the compiler, various platforms that it can be run on, how to test it, lots of documentation so that you can go much farther than we're going to take you beyond just the C language. You can go into all of the linking and other kinds of things that we'll see a little bit of later on in the tutorial here. But right now, we just want to make sure that that compiler is out there and running and relatively up to date. We're not going to use an integrated development environment, an IDE, or anything like that, even on Linux. We're just going to use the simple command line or terminal session, just like that, so that it's nice and simple, and we only have to worry about the language itself and not some IDE getting in the way. So onward, we will go and learn how to test our compiler and make sure that it's actually out there. Now we're going to test our GNU C++ compiler, or just C compiler. It's pretty simple, but I want to show you something interesting in Linux about the CPP and what it's called. Let's switch over to our Linux, and as you can see, we have our term session running. That's all we really need. If you get your system started up and you're used to just a clean desktop, maybe some icons out there, you may not use the terminal very much. Well, the terminal is right up here, and in the other operating system, the other big one, Windows, that's called a DOS prompt, or the old disk operating system command prompt. Well, here it's a term session, or terminal, and you saw the word terminal pop up there probably at the top, and that gives us control over the system. It gives us a command line processor that we want to be able to use to keep the IDE and all the graphics and all that out of our way while we're learning the language. So now that we're here, we've gone through all the updating, the CPP, the package manager, the RPM, whatever it is your particular flavor of Linux requires, and we believe that there's a compiler running, or available, I shouldn't say running. Let's now make it run. GCC is the compiler that we installed, and we'll put a space, a dash, and a V for version. We want to learn the version that this compiler is going to run just to kind of make sure it's out there. Well, there it is. There's the i486 Linux GNU and a lot of configuration information that we don't really care about right now. But there's our GCC version 4.03, and it's on the operating system, Ubuntu 4.03, as you can see that, so on. Well, GCC, the GNU C compiler, that's one word that can be used to start this thing. There's also G++ space dash V. Gives us exactly the same information because it's pointing to exactly the same program. This G++ is just a different way of asking for the C++, the GNU C++ compiler to run. What you'll find in the ANSI C book, the KNR that we're going to use, is they call it CC, the C compiler, because that's what it was originally called when it was written for Unix. If we do a CC space dash V for version, exactly the same information, because they understand that a lot of older commands use CC for the C compiler. So they get that CC pointed or linked over to the new compiler that we just installed so that everything runs properly. Just wanted you to know that if you want to use the CC command that we're going to see in the book, that's quite all right, and it will work just fine. Okay, we've tested our C compiler under Linux, and we're going to move onward. We did all this work to install a compiler on Windows and to install a compiler on Linux. Just what is a compiler anyway? A compiler is a program that converts human-readable instructions into computer-readable instructions one time. A compiler takes longer generally because it rearranges or compiles or optimizes what is then called object code. We're going to learn how to write a lot of different instructions and statements and functions and things like that. And they're not necessarily going to be in the best order for the computer. They'll be in the best order for us to think about how things should work, but the computer may have a better idea. And it knows, the compiler knows what it takes to make better machine executable code. And that's what it's going to do for us. An interpreter is a program that converts the source code or human instructions into the machine instructions each time you interpret or run the particular program. An interpreter starts interpreting each of the instructions, go to here or print this or take input from the keyboard. It interprets those immediately and appears to produce results more quickly. However, the interpreted program will almost always be slower than a compiled output or compiled program. An An interpreter is very good for reviewing the functionality of a program with your customer. And you can sit down with them and say, what if we change it like this? And what if we do that? Is that more what you want? So it's very good for development reviews. When we're compiling, the source code goes into the compiler. It is optimized and turned into some standard code that the compiler has within it, which produces object code. Now, the object code cannot run by itself. The object code generally needs to load DLLs, dynamic load libraries, or other code that is necessary for the program to actually function. We don't need to write all the operating system programs over and over and over again, so there are libraries of that code already created that will be linked in with our program. And of course, to do that, we use a linker. A linker takes the standard libraries, our object code that we created from our compiling process, and any user libraries that we might have made or our company might have made. A number of programs that get used a lot to maybe run a piece of machinery that our company has created or something like that. All of those libraries and object code get linked together by the linker, and that produces an executable program, something usually in the Windows world that ends with .exe that we can actually run on our computer and cause some work to be performed, which is why we're learning how to do this. So to recap, a compiler, the program we've just installed, is going to take our C programming instructions and it's going to turn them into object code. The link step is then going to link our object code with some standard libraries that already exist and produce an executable code. So we're going to see all that happen as we do this, but I want you to understand the difference between source code, which is what you can easily read, written in a form of English, object code, which is the output of the compiler, and then executable code, which is a combination of object code and other standard libraries, and maybe even some user libraries, so that we can get an executable program to run. So let's go forward and enter our first program and compile it and link it and execute it. And then I'm going to give you an assignment, a little bit of homework to do.